Hello, so today we're gonna, you know, walk through how to build a Titanic survival model, I guess. I think a lot of tutorial is like treat speak a lot of theory, but not actually walk through the process. So I guess it's good to walk through the process and understand it from first principle. Yeah. So yeah, according to Titanic, we try to measure the survival rate, right? And it's either they survived or they didn't survive. So we represent it with zero and ones. And the survival rates, might depend on their sex, their class, their age, siblings, patch, fair, embarked, and it depends on many factors. And what we try to create is a model that successfully predict the survival rate based on this informations. You could think as these are the independent variables. Um, and these are the dependent variables. So let's walk through. So we're gonna first import a bunch of libraries. Um, so it might be like because computer science they don't have you're not gonna type a lot of formulas. So what computer science do is you have bunch of libraries. Um, it might look very daunting at the start, but it's just think of this as a size like a math book, right? And a uh, you might have a linear algebra math book or probability math book, and you want to get the formula from the math book. For example, uh, we want a logistic regression model, right? And we want to import this formula from this book, and that's what we're doing. And yeah, because no one want to type in complex formulas in code, and that's why we're trying to import a lot of libraries. So right, the first thing you do is to define some data paths. So yeah, we want to know where the address of the file is, so that we could access that file. And this is the main function. This is just where we put our code and we have started. So and this is the panda. So what panda do is Python can read, you know you have a CSV file, right? A CSV file, and panda can read it. So what we try to have is use panda and then read the panda just convert it to like a readable file for Python. So yeah, and then we use like we store this in data. And for the feature columns, so what we want to define is the x and y variables. So for the what's on the in the bottom, we definitely got class, sex, age, siblings, patch, fair, embarked, and what we try to measure is the survival rate. So yeah, and what this do is it so this just strips the first thing, we got the data, we take out this data, we strip the columns, and then this just strips you know this type of columns. And then the survival, and then the survival, and then this target columns just strips the target columns, you know so yeah. And then T, we define the numeric features, and we also define the categorical features. So numeric features are like, things are like 0, 1, 2, the numbers. And then categorical is, you have a sex, you have male or female, you know. you can't define them by numbers. And what we do, we try to pre-process this data because sometimes data can be messy. So, for example, you have sex, you have male and female, right? You can't represent that in like a data perspective. So we try to turn data into numbers so that we can um, we can uh, plot everything together. So and then we try to normalize the all these numeric features because we want um, because sometimes the numbers could be super big. So like take this example. You have obviously like sometimes the numbers are pretty expensive like this, right? And then and then it's like you try to have normalize it so it doesn't get too big and too small. So yeah, and let's just see the normal. And it typically is something like something like this. You could look more into it if you're interested. And yeah, this is how we pre-process data. And then what the pipeline is, it's just it runs your model. So yeah, we have preprocessors and classifier. So you just think like a conveyor belt, right? You might have one machine that assembled it and one machine that builds it. And pipeline is just like it runs it automatically for you in like a conveyor belt, right? And then here we split the data for training and testing. Um, yeah, and then because think how we have this much data, right? We can't have we can't have uh, more data other than this, right? We want to split us. We have to have some data for testing and training. We can't have more. Uh, we don't have more data to work with. So and then yeah, this is just split the sizes, I guess. Yeah, and then this is a different make a random, right? And then yeah, and then we try to fit the model in regression, and that's and what logistic regression look like. You might wonder. Um, yeah, so this is what logistic regression look like. Mm, yeah, so what happens is that we have think XY graph. We have let's take this graph. We have a lot of points on this graph, and each data we can plot is plotting a point in this graph, right? And then um, yeah, and then we use like linear function, right? We use something like uh, you know, with like a linear function to plot it. And what this do is just it finds the weights, and what the weights is just the coefficient for this, and then we try to plot all the points in a line. But instead, we're doing a 3D, in a 3D environment, and we try to craft, a a line through all the points, and that's best fitted. Then the model use a sigmoid function, and yeah, so there's a sigmoid function, and what it do is it basically it's between 1 and 0 and 1. So you try to we have a bunch of values, right? So you try to um, make a probability because the probability is 0 to 1. So we try to shrink it, and that's what this fitting function do. And then prediction, right? Obviously, we try to predict it. Um, after we have the line, we have it in the line, we try to predict the value for the x test since we split it. And then accuracy, we don't know how to calculate accuracy, right? So we just y test over prediction, and how accurate it is. And then these are a bunch of yeah plotting, just um yeah just printing a bunch of stuff. And then here we have more examples where you try to um predict. So, and then we can predict the exam, and we can predict the examples, and yeah, predict the probability, and there's just printing. Okay, let's run this. So let's yeah. So we get something like accuracy equal to 0.75, and yeah, and this is and you also predicted the passengers. So yeah, for this guy he did not survive, and then for this guy he probably survived, and these are the probabilities. So yeah, and that's it for pretty much. And I think the mental model is, not to really try to code that much, but try to understand what's going on, right? How we find the data, load the X and Y, prepare and process the data, and then build a pipeline, split it, train it, and then prediction. I think, yeah, this is pretty important to understand.